Mathematics is often presented as a clean, neutral, perfectly logical subject that simply grew over time. But the truth is more complex. The history of mathematics is not just a timeline of discoveries. It is a story shaped by power, culture, conflict, personality, and strong opinions. It is an opinionated history. Ideas were not accepted because they were always correct. They were accepted because someone defended them, proved them, fought for them, or sometimes because society was finally ready to hear them. In ancient civilizations, mathematics developed out of necessity. Egyptians measured land after floods. Babylonians tracked trade and astronomy. Indian scholars refined number systems and introduced zero as a formal concept. Greek mathematicians formalized proof and logical deduction. But even in these early periods, mathematics was shaped by philosophical beliefs. For the Greeks, numbers were not just tools, they were sacred. The discovery of irrational numbers shocked them because it contradicted their belief that all quantities could be expressed as ratios. Instead of celebrating the discovery, some resisted it. This was not just mathematics, it was ideology. Centuries later, during the development of calculus, we see another example of opinion-shaping progress. Calculus did not emerge peacefully. It was developed independently by two brilliant minds, and what followed was not collaboration, but controversy. Accusations of intellectual theft overshadowed the mathematics itself. National pride influenced reputations. Entire communities aligned with one thinker or the other. Mathematics, often described as objective, was entangled with human ego and politics. Even negative numbers were once controversial. Today, a negative number is trivial to a child learning arithmetic. But for centuries, mathematicians debated whether negative quantities were real. Some called them absurd, others described them as meaningless. It took time and practical application for acceptance to grow. Similarly, imaginary numbers were dismissed as impossible. The term imaginary itself reflects skepticism. Yet today, complex numbers power electrical engineering, quantum physics, and signal processing. What was once considered fictional became foundational. The 19th century brought further tension. Non-Euclidean geometry challenged the long-standing belief that Euclid's geometry described absolute truth. For over 2,000 years, Euclid's axioms were treated almost as sacred. When mathematicians proposed alternative geometries, many resisted. It felt like attacking certainty itself. Yet these new geometries later became essential in understanding space, particularly in modern physics. Again, the story was not smooth acceptance. It was resistance followed by transformation. The 20th century intensified this pattern. Foundational crises emerged. Mathematicians debated whether mathematics was discovered or invented. Formalists, intuitionists, and logicists argued about the nature of truth itself. Could all mathematical statements be proven from a complete set of axioms? Many believed so. Then came a breakthrough result showing inherent limitations in formal systems. The idea that mathematics might contain truths that cannot be formally proven was unsettling. It challenged the belief in mathematics as a perfectly closed system. Even here, opinions divided scholars. But beyond intellectual debates, there is another dimension to this opinionated history, whose stories were told and whose were minimized. Contributions from various regions were sometimes ignored in dominant narratives. Mathematical history often centered on certain cultures while overlooking others. Over time, historians worked to rebalance this perspective, recognizing the global and collaborative nature of mathematical development. Mathematics was never the product of a single civilization. It evolved across cultures, languages, and generations. The history of mathematics also shows that new ideas often face resistance not because they are incorrect, but because they disrupt established thinking. Radical abstraction in algebra, the rise of set theory, the formalization of logic, each encountered skepticism. Innovation requires courage. Mathematical pioneers were not only thinkers, they were challengers of norms. They had to defend unfamiliar ideas against established authorities. What does this mean for us in 2026? It means mathematics is not static. It is dynamic and human. It grows through debate, disagreement, and revision. It reflects both rational structure and human perspective. Even today, fields such as artificial intelligence, data science, and computational mathematics continue to evolve through bold new abstractions. What seems controversial now may become foundational tomorrow. Understanding the opinionated history of mathematics teaches us humility. It reminds us that certainty can be temporary. It encourages openness to new structures. It shows that disagreement is not a weakness of mathematics, but a strength. Through critique and refinement, ideas become stronger. Mathematics progresses, not just by solving equations, but by questioning assumptions. So when we study mathematics, we are not just learning formulas. We are participating in a centuries-long conversation shaped by debate, culture, philosophy, and imagination. The subject may strive for objectivity, but its journey has always been deeply human. Mathematics is logical, yes, but its history is opinionated, contested, and alive, and perhaps that is what makes it powerful.